Hi everybody, my name is Vin Yu, and in this session I will be talking about SQL Server security, SQL Server agent, monitoring, and troubleshooting. Just to provide a little bit of background, I am a program manager on the SQL Server engineering team. I am focused on SQL Server on Linux features, developer experiences, and the next version of SQL. As mentioned, in this section we will have four subsections. We'll be covering security, agent, monitoring, and troubleshooting. So let's get started with security first. So in this section, there's two agenda items here we want to cover. In the first section, we're going to want to cover some of the security features available on SQL Server Linux, and then cover some of the differences between some of these features on Linux and Windows. Now, if you've been following the news over the last few years, you probably don't need to hear this from me, but today, data security is more important than ever. As companies have more data, the cost of data breaches increases. But because that is with every record, there may be more costs associated with each one. The global cost of data breaches has been estimated to rise more than $2 trillion in the next few years, and these risks are relevant to every company that handles data. Organizations are giving higher and higher priority to data security, and yet data security is still perceived very painful and hard. Which brings us to SQL Server, where our security features are built in right into the product. They are easy to use, require minimum changes to the application code as well. All right. So let's get started about protecting your data first, which is about encrypting your data, whether it be at rest or in transit. SQL Server does have the technologies to encrypt this data no matter where it is. So for example, encryption at rest is a very common requirement for customers who want to protect the data in case the files or disks are stolen. SQL Server enables you to protect your data at rest with varying degrees of granularity with features such as TDE, also known as transparent data encryption, backup encryption, or cell-level encryption. I want to highlight transparent data encryption first because it is so commonly used. This feature encrypts your entire database, the data, the log, and the backup files without requiring any application changes. It works on Linux the same way it does on Windows. The second type of encryption is called encryption in transit. This means encrypting your communications with SQL Server using the latest industry standard TLS protocol. Just like on Windows, SQL Server supports TLS 1.2 support on Linux and can be configured to be FIPS compliant. The last type of encryption I would like to call out is the client-side encryption. SQL Server on Linux now supports a feature called Always Encrypted, and here's how it works. Always Encrypted enables you to protect highly sensitive columns of data such as SSNs or other PI data, or even such that even high-privileged database administrators cannot access this data in plain text. This works by encrypting the data on the client side and typically requires minimum changes to your application because our enhanced client drivers such as the ODBC driver or the JDBC driver handles all the encryption and decryption for you. Because the data is encrypted before reaching the database, it's never going to be stored in plain text. Now, so back to our diagram, we just talked about encryption. The next layer of security is about controlling the access, authentication, and authorization. Right. So SQL Server has two types of control features: database access, which controls access by users who connect directly to the database, and application access, control access by end users who connect through an application to the database. Now, on the database side, for example, SQL Server has very granular permission systems, allowing you to control access to specific tables or even individual columns of data. But in particular, I want to highlight, just like on Windows, SQL Server on Linux does support Active Directory authentication. So we'll cover a little bit more of that later on. While features like permissions and AD authentication control access at the database layer, SQL Server also supports several programmability features that make it easier for you to control which data can be accessed through the application layer. For instance, row-level security allows you to control access to specific rows in your table based on the end user. By attaching this logic to the database itself, you simplify your application code and reduce the risk of accidental exposure. Right. Similarly, dynamic data masking allows you to mask query results on the fly according to a centralized policy within the database. For example, you might only want to expose the last 4 digits of an account number or the domain of an email address of users in your application. Again, by having SQL Server enforce the masking policy, you simplify your application code and reduce the risk of accidental exposure. So now that we've covered encryption as well as controlling access, let's look at the most outer layer, which is about monitoring access and keeping track of who does what in your database. Just like on Windows, SQL Server supports a fine-grained audit feature, which allows you to track and log activities relating to users, actions, and objects. This feature is commonly used by customers who need an audit trail in order to meet certain compliance standards. So there you have it. That's in a nutshell. That is a tour of all the layers of security in SQL Server. So one thing I'd like to point out here is that SQL Server on Linux supports all the same capabilities as SQL Server on Windows today, as mentioned on this chart. The features in green are the ones that work same across Windows and Linux. So there are no changes there, which brings us to TLS, Transport Layer Security, and Active Directory. There are some differences on how these features are set up. So let's just take a look at how those differences are. All right. So transport layer security differences. So here we're just going to walk through some of the general steps and then point out some of the differences between Windows and Linux. So the first general step to setting up TLS is to obtain a certificate or to generate one. On Windows, this is typically done by using IIS to generate a self-signed cert usually for development and testing purposes, which underlying uses Windows. There are also a bunch of other tools that could be used to generate one of these certs. And on Linux, we would use OpenSSL crypto. Right? Installing these certs on Windows, you would use the Microsoft Management Console. On Linux, we'd be copying and pasting this into the file system. To configure SQL Server to use these sort of certificates, on Windows, you would be using the SQL Server Configuration Manager. And on Linux, we would be using MS SQL Conf, which is a command line tool to set this up, as well as the Linux file system to putting these files where they're supposed to be. So just to highlight, on how to encrypt some things about encrypting connections on Linux using TLS. So not only TLS 1.2 supported, but we are also back compat supporting 1.0 and 1.1. To use so TLS is used, on the client. You would have to configure your client application to do this. So you would specify encrypt equal true and trust server certificate equals false in the connection string. So as mentioned in the previous slide, this is built on a OpenSSL stack, and it is FIPS compliant. Now, the second feature that I want to point out where there's some differences around setting up Active Directory, is Active Directory authentication. So the general step, I'm just going to list out some of these steps and then point out the difference between Windows and Linux. The first step is you would have to join your SQL Server host to Active Directory domain. On Windows, this is done through your control panel. Okay, on Linux, we would actually require you to use realm-d commands. So this is actually existent in the realm package. You would actually have to install this separately. The second step is to create an AD user for SQL Server, the SQL Server instance, and set the service principal name. On Windows, this is done automatically by the SQL Server process every time SQL Server boots up. On Linux, you would actually have to configure manually create the AD user on a Windows machine that's connected to the domain controller, right? Or connected on the same domain. And this is done with PowerShell, the PowerShell command new AD user, and running a set SPN binary to get the service principal name set up. So the next step is configuring a SQL Server service key tab. On Windows, again, this is done automatically at the boot up time, so this is not, you don't have to do this. The key tab file contains the service principal and the encrypted keys so that AD users could connect to the SQL Server service. On Linux, this is achieved by using the KTutil tool on Linux, and MS SQL Conf to tell SQL Server instance to use that key tab, right? And the last step is to create an AD-based login in T-SQL. This is the same across Windows and Linux. So here we have a simplified diagram where we have the user, the AD controller, and the SQL Server machine. So starting on the user side, once the host has joined the AD domain, the user will need to use the kt init command, which will authenticate the user with the domain controller. As a result, the user will get a key ring, which could be used to connect to other objects in the same Active Directory. Now, on the SQL Server side, once AD account for the SQL Server has been created and the service principal name has been set with the fully qualified domain name of the SQL Server host, we can use the kt util tool so that we can link the SQL Server instance with the service principal name. The result of using the kt util tool is that we create a key tab file, which could then be used to accept AD connections. Right. We would then use MS SQL Conf to tell SQL Server, hey, where to look for the key tab file to use. All right. So with that, let's go into a demo where we can show, how to connect to SQL Server on Linux using AD auth. Okay. So currently I am logged into my machine, and what I'm going to do next is log into AD by using kinit. And with that, I have logged in through AD. So now I'm going to try to connect with SQL CMD. So I'm going to use the E flag, which specifies that I want to connect using AD auth. So here you notice that it failed because that's because on the SQL Server instance side, I actually have not set up my key tab for usage yet. Right, so the SQL Server instance needs to be linked with the AD service account as well as the SPN, which is done with the kt util tool. So to save time, I actually already ran the kt util tool to create the key tab ahead of time. And so let's just take a look at the key tab contents itself. So here I'm looking at the key tab contents itself, and what you do see is that there's two entries in here with the SQL Server service accounts and the SPNs with the fully qualified domain names that I want to connect to. So here you might also notice that there are two entries. There's two entries because there's one for each encryption algorithm that's available. Right. So with that, so now that I have the key tab file, I have to make sure that SQL Server can actually use these files, use the key tab file. So with that, so here I'm just going to copy. So here I'm just going to copy over command so I don't make a typing mistake. So here what I did was I used MS SQL Conf to set the network Kerberos key tab file, and I specified the path of that key tab file. Now I'm going to run restart. So now that at this point, I have the user logged in through AD, as well as having my SQL Server instance configured with AD as well. So let's go back and try to connect. And with that, I was able to connect using AD auth. And that concludes the SQL Server on Linux security overview section. So in this section, we're going to cover agent. So SQL Server Agent is a job execution engine for SQL Server and can be used for jobs on the database or on the data itself. On Linux, this can be managed by SSMS just like on Windows, and the SQL Server service actually runs inside of the SQL Server process, right, on Linux. So some of the common use cases are for maintenance, monitoring, data import, export, or just running anything T-SQL on a periodic basis. It is also used for log shipping, which is a process that takes the logs from a SQL Server database and exports it to a remote server and replays it for a disaster recovery site. So I have two docs on the slide here for you guys to look into, to look at more, to understand how we can use SQL Server on Linux and Agent. And with that, let's go into a demo of using Agent for T-SQL jobs on SQL Server on Linux. All right, so let's get into our demo with SQL Server on Agent. So what I'm going to do here is just create a very simple job of taking a daily backup. So the first thing I'm going to do is create a job called Daily Sample Database Backup. And the first thing I'm going to do is create steps to that job. So here you can see that I'm taking a backup of the database, of my database called Sample Database here, right? And then I'm also going to create a schedule called Daily, where I'm actually setting the schedule to a daily time. Then I'm going to set the daily schedule to this daily job. And then I'm going to add this to the job server. I'm going to apply this to my local job server, and then I'm going to execute this job. So right now you may notice that under SSMS, there are no jobs under my Object Explorer, under SQL Server Agent. So then I'm going to go ahead and just execute all these commands. And here it says that my job called Daily Sample Database Job Backup has been successfully created. Then I'm going to go here and just refresh my Object Explorer. And under SQL Server Agent, we're going to see a daily sample database backup, right? So, you could also monitor agent jobs here with the view job activity monitor. So you can see I can see the status of what it's currently doing, when it was last run, if it's enabled, and other metrics about this database job. And that concludes our section on SQL Server Agent. It is very similar to SQL Server Agent on Windows. So going to our next section, we're going to talk about SQL Server monitoring. All right. So this has majority the same. So monitoring SQL Server on Linux is the same experience as it is on SQL Server on Windows. All the DMVs from SQL Server on Windows are also available on SQL Server on Linux. All the third-party tools connecting to a SQL Server instance will continue to work, as most of it just relies on the DMVs. All right. So with all the DMVs available, you can query these DMVs to get the status of your workloads, or continuously query these DMVs to build out a dashboard. So let's see an example of that. All right. So here on my browser, I have a Grafana dashboard. Essentially what this is an entire SQL Server monitoring solution that's built solely on DMVs, right? So here, this dashboard is an open source dashboard, and I'll explain in a bit how this works, but just browsing all of the information that you can get from a DMV, you can get CPU stats, memory stats, IO stats, as well as information on perf counters. So here I ran at about, in the last few hours, I saw that there was a huge spike in transactions per second and particular write transactions per second. So there's a lot of information that you could gather from DMVs. All right. All right. So what I was and that was the demo I just shown. So just a little bit more about what I just showed you. This Grafana dashboard depends on two other additional components besides Grafana itself, which is just a UI layer. Telegraph, which is an agent, it is continuously querying the SQL Server on Linux environment, and is pushing these metrics into a time series database known as InfluxDB. The data is then just visualized by the Grafana dashboard, which reads the data from InfluxDB and when a Grafana requests it. All right. So, and a little bit more about monitoring itself, we have also been working with our monitoring partners to ensure that they do support monitoring of SQL Server on Linux, right? So here you can see a few of the partners, and we have a doc link below that talks about as we continue to work with more of our partners to ensure that they do support monitoring SQL Server on Linux. All right. So which leads into our next section on troubleshooting. Right. So when we talk about troubleshooting in this section, we're not talking about troubleshooting of your T-SQL workload. What we're really focused on is, hey, what does SQL Server look like on Linux, on a Linux operating system? So here are some of the questions which walks us through a path of how we're going to approach troubleshooting from the Linux system, right? So we're going to cover some topics such as what does SQL Server look like from the perspective of my system, how do I manage the service, how do I start it, what happens when SQL Server stops, where do I start looking at it, how to resolve network issues, as it is a very common issue, as well as what tools can I use to gather for the diagnostics so I can use it for troubleshooting. So what does SQL Server look like from the perspective of my system? If you use top, this is a utility that comes with most Linux systems, for sure on Red Hat, and as well as Ubuntu and SUSE, which are the three distros that SQL Server supports on Linux today. So when you type in top in your console, what you're going to get is an output that's very similar to what you see on the slide here. And you can see that it looks very similar to the task manager of Windows, right? So here you can see, how much CPU is being consumed by each process and how much memory is being consumed by each process, and you can sort it in either way. And this is all achievable. This is all available in the command line. Right? So if you are just SSHing into your SQL Server on Linux, you could grab this view, right? So now that we know what SQL Server looks like from the perspective of my operating system, let's learn about how we manage this a little bit. So as you may have seen in one of the previous sections of today, systemctl is the utility that we use to start SQL Server, to stop SQL Server, to check its status, as well as restart the server, right? And so when I do run a systemctl status on MS SQL Server, this is what you're going to see. You're going to see it being active or unactive, depending on the current state of your SQL Server. And one thing to notice here is that we have two PIDs. One of them is actually the parent thread, and the other one is the child thread. The parent thread is actually responsible for launching the actual SQL Server instance. Other responsibilities of the parent thread is to monitor it and to make sure that there's nothing going wrong with it. Right. So one of them is the parent, is essentially a launcher of the SQL Server instance. So SQL Server is launched and managed by so we talked about systemctl, right? So what's actually launching it? What's actually calling underneath it, right? So SQL Server is launched and managed by systemd, which is a service manager for Linux operating systems. So for each service, there is typically for each service that's managed by systemd, there's typically a systemd unit configuration file. So SQL Server is no different. There is a unit configuration file located in this directory of under user, library, systemd system called MSSQL Server, mssqlserver.service. So if you were to take a look at the contents of this file, first of all, this file defines how SQL Server should be managed at startup by the system, as well as some of the limits that we put in there by default. So for example, when looking at this file, what you may notice is that, hey, there's a service component of this file, and it's an exec start. Essentially, the binary of SQL Server is at this directory. So opt, MSSQL binary, or bin SQL Server, right? And there's some other configurations that we also place in this file. For example, if SQL Server started and shut down and start and shut down too frequently, they may cause problems. So by default, we make sure we put a throttle on this such that you cannot restart your SQL Server instance more than 3 times in 2 minutes. Now, if you change this unit file, then it will change the way SQL Server is managed by systemd, right? So where can you get more? Where can I get more information about the SQL Server service? So we talked about, now at this point we know how to manage, how SQL Server is managed and run, right? One thing you might ask is, well, how do I get more information about SQL Server as it's running, right? What logs are there on the Linux system? One tool that you could use is journalctl and journald, right? So by running journald, essentially what this is most of the applications that are configured by systemd will also take in logs from the applications or services that it is managing. So in this case, I'm running journalctl and I'm specifying the name of the service with the .u flag. And here you can see a timestamp, the user, as well as the name of the processee, and whatever the processee or service is spitting out to to the journals. Right. So the next common troubleshooting is, we have a lot of customers or users that might say, hey, SQL Server stopped, won't start, hangs, where do I start? The first place that we tell most of our customers to go to and users is that to look at the log directory, which is available under var opt MS SQL log directory. And here you're going to find a few types of files. I'm going to go over these files and what they mean. Right. So here there's an error log file. An error log file is generated every single time SQL Server is restarted or started. Right. And so there is also a set of core server files. These are core dump files, essentially, that are generated automatically by the parent process when SQL Server crashes. So as mentioned earlier, SQL Server, there are two PIDs, two processes. One of them is a parent process, the other one's a child process. The parent process will actually trigger a core dump if they find that there's something wrong with the SQL Server engine, right? So here there are other logs, which are default traces enabled by SQL Server, and there are also system health, and hackathon related log files as well. Right. So if you were to take a look at some of the files in this directory here, for example, we're going to see that there are a few core dump files. There's several error log files, and the error log without the new number attached to it, this is the most recent error log file. Right. So this is the most recent started instance of SQL Server. And one thing that we do that our customer support team may ask our end users to do is to generate the dump manually. So let's say there's something wrong with SQL Server, both the parent process and the child process is hung for whatever reason, or you're getting to a point where there's something really wrong with SQL Server. Our customer support team may ask you to manually generate a dump. And this could be very useful for us to troubleshoot what's wrong in your environment or in our customer's environment. So the usage of this is, there is a script called handle crash, right? So in here you would specify the program name, the process ID, which is the process ID of the engine and not the parent itself, because that's the dump we want to generate for. The program directory, dump directory, of where you want to dump it, the instance ID, and the crash ID, and whether you want to kill the process shortly after or you don't. Right, and here's an example of what that might look like. So up to this point, we talked about, hey, how can we troubleshoot SQL Server by looking at some of its logs and how SQL Server is started by the system. Well, what if we want to monitor SQL Server proactively? So as mentioned in one of our previous slides discussing how SQL Server is started in the configuration unit file, you can also call that binary directly by launching opt MS SQL bin SQL Server, which launches this in the foreground, right? So this is really good for dev test scenarios and real-time use cases. Another common area of troubleshooting to make sure that you could connect to your SQL Server is to ensure that you resolve all the network issues for SQL Server. These are some of the general checks that we recommend you check if you are running into any network related issues, such that at this point you could run systemctl status on SQL Server and you know that it's running, but as an end user or from an application perspective, you cannot connect. Right. So the first thing we ask that you check is that you're connected to the correct instance and host. The second is to ensure that you have opened up the SQL Server port, and by default this is 1433, but if you have configured SQL Server to listen to a different port, just remember that you do have to open the firewall on your OS as well. Right. And also, if you are running on a public cloud such as Azure, make sure that the network interface on your cloud is also opened to allow connections coming in. Right. So one way we could check which port SQL Server is listening to is actually to look at the error log file. When SQL Server is starting up, it actually prints out which port it is listening to. So in this case, we're listening to 1433. 1434, which is for administrative connections, and 5022, which I'm using for HA, right? So, and because there are multiple error logs, we want to look at the most recent value because this is the one that has the current status of which port SQL Server is listening to, right? And to add a firewall rule, we would use on RHEL, we would use a firewall CMD, and this command at the very top here, and this would add the port to open up the port for allowing access into SQL Server. Right. So there are also some other tools. I mean, these are not all the tools that are available that you can use to troubleshoot SQL Server on Linux, but PSSdiag is a general purpose tool that's created by Microsoft, and that allows us to collect various logs and data files on your system. PSSdiag can natively collect system monitor logs, SQL Server telemetry, as well as a bunch of other types of log files on your system, a bunch of other files that's on your system. So this is actually used by our customer support team to troubleshoot all the issues, and there's a link here if you want to learn more, as this is an advanced topic. And that wraps up our monitoring and troubleshooting session. Thank you.